Miha. So let me try to move a little bit faster than planned, just to have enough time to cover all the material. I would like to talk about a new and upcoming technology that we believe is very disruptive. And basically, the main goal here is that we would like to offer a way for you to commoditize what is creating your own Postgres, what we call building your own Postgres cloud. Before just starting, let me make a brief introduction about myself. I work mainly on R&D and doing what I call stupid projects all day. Some of them end up being maybe not that stupid, right? And I'm the founder and CEO of a company called OnDB, which means on Postgres. And so this is one of the projects that I started some time ago. I want to present today. So probably you have attended the keynote I presented yesterday. I'm just going to do a brief recap to set the stage. Right? We all chose Postgres because Postgres is open, because we can see, we can inspect, we can touch, we can look at the source code, we can install what we want. But the reality is that today, many of the cloud services expose a proprietary interface. And we have lost the openness part. We can still use Postgres, so we get the engine, but this engine is proprietary now. So we lost something. And let's look back at what we were doing when we were self-hosting. When we were self-hosting Postgres, we had this freedom. We could do anything we wanted. We could install anywhere, on any data center we wanted. We could install any tools that we wanted, on any computer hardware that we wanted. So we had this freedom. So we have transitioned from the era of self-hosting, when we had the freedom to install anywhere, to install under our own terms with our own tools, now back to an era where we cannot, right? So, but the main reason why we have transitioned about this is that Postgres is just not a single component. Postgres is kind of a kernel. And we need tools around it to make it work. So each of these tools actually, because it doesn't come with Postgres, it's kind of a bit of a rabbit hole. There's many tools for high availability. There's many tools for connection pooling. There's many tools for backups. There's many tools for everything, right? And all these components do not come with Postgres. I need to look into the ecosystem, install them separately, configure them separately, and have a lot of expertise and time and effort to actually be able to do this, right? So database as a service came. And database as a service is a very compelling alternative. I like it very much. I would recommend you every time that you want to use a managed service. Because few clicks, or actually like click, 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 like a lot of clicks, but you get it, right? In a couple of minutes, you still get your Postgres cluster up and running. And it's production ready, it uses best practices, so it's a pretty good deal. So again, it's a very compelling option. But as always, there's trade-offs. They say, when people use a managed service, they say, oh, we use a managed service because they, meaning the cloud, manage it for us. But who is they? Is there someone there behind the screen typing commands fast when you click on the web and then provisioning your Postgres cluster? Well, obviously not. It's obviously software. So a managed service, in reality, is no more than software. This software didn't exist in the open space, in the open source, when managed services came up. But it actually exists today in some other ways. So let's look a bit about the trade-offs that we accept when we go on a cloud managed service. And one of the most noticeable ones is cost. We can do many comparisons and many examples. This is a basic one, comparing the price of a managed service on RDS versus the cost of the same instance if you just get the instance. We're talking about almost double the price, just because it's a managed service. And it can get even worse. If, for example, we try to leverage local storage versus network storage, which actually drives up the price dramatically. So if we, for example, compare a 3-node cluster versus as a managed service versus the cost of having an instance, a 3-node instance cluster, where I store the data locally with an MVM, it drives it out there. And use for application to ensure durability, then not only I go 5 times cheaper, but I even have a much faster disk. comparing 40K IOs against 256 IOs. So there's very compelling options to think about having your own cloud on your own terms. Right? The problem again was that this software didn't exist. It's starting to exist now. And so the question is, can we bring back this conveniency that clouds bring? The easy of creating something very, very fast, but on my own terms, on my own environment, with my own rules, so that I can install any tools that I want? And the answer is, as you can guess, because I'm here, yes. Or it's about to happen. So I would like to introduce a project, open source project called OnDB, which means own your database. Right? And the idea is that you can create a fully open and fully sovereign, meaning it's yours, Postgres cloud. You can manage Postgres fleets, you can manage Postgres clusters, single instances, you name it. And you decide where you want to run them. Do you want to run them in the cloud? I think it's a great option. You create your instances, you deploy there, you run there. You want to run it on-prem? That's fine. You can run it on-prem on your own hardware. You can mix and match. Maybe one node in the cloud, one node on-prem, one in another cloud. Perfectly fine. It's your decision. And this doesn't require anything installed. There's projects, I'm behind the side of one. There's been a presentation here before from Cloud Native 2G. I'm also behind a project called Postgres, which is pretty much the same idea, right? A very complete operator that runs on Kubernetes. But we wanted to also offer an option for people to not having to depend on Kubernetes, just their Linux. So give me a bunch of Linux boxes, and I'll create a Postgres cloud for you. That is the promise behind OnDB. So let's look a little bit about how we can achieve this. I want to go a little bit technical now and take a little bit of a deep dive on the architecture of what we have built. And then I'll try to do a demo live. Anyone wants a demo? Live demo, live code, live risk? Yeah? Okay. No, not enough. I'll not do it now. I'm kidding. I know the translation. I'll try to do that. Okay? So let's get about the architecture first. So first we have the component called Slomi. So Slomi is the plural in Russian for Linux. For elephant. So we have multiple elephants. And Slomi is a component that actually is able to manage what we call a Postgres execution environment. In other words, a place where you can run Postgres. If you have a Linux box, and by the way, we'll have also other boxes around Linux in the future, but for now it just works in Linux. Give me any Linux, doesn't matter the distribution, the version, anything. Just give me a Linux, install Slomi Linux, and then now you will be able to create Postgres environments there. Okay? This is run by a gRPC API, so it's controlled remotely via gRPC. So install is one command, install the Slomi on any Linux, then you've got what we call a managed node. And now we can create Postgres inside. We'll see this in depth. Then we have, this is by the way, the architecture diagram. It's very simple. gRPC API, this is Slomi, installed on a Linux system, and it can create a Postgres execution environment. Let's look at the other component called Slon. Slon is a single elephant in Russian. So it manages one Postgres. Slon is essentially a wrapper over OnDB, ptctl, and those commands that you need to start Postgres, also for patroning, also for apps patroning, but it's controlled again by a gRPC API. Our goal is to control the initialization and lifecycle of Postgres instances remotely. The architecture looks similar, but it's not the same, because this is running within this Postgres execution environment, which, by the way, it's a container, but it doesn't matter. You don't see this. You don't need to install anything. It doesn't depend on Docker. You have no dependencies, zero. Just Linux. So with Linux, we can create Postgres execution environments, and inside of them, there's a controlling unit called Slon that manages Postgres and patroning, and is controlled remotely via an API. You will see why we are following this architecture. And of course, we can create multiple Postgres instances within a single entity, a single instance, a single server, a single Linux. Okay? We can create as many as we want. And finally, there's matriarchy. Elephants, I'm not sure if you're familiar with this, but the leader of the elephant herd is the eldest female, called the matriarch. So the matriarch is the controller, is the brain, is the cloud. It's the entity that controls everything. So basically, all Sloanies, the Linux servers managed, and all the Postgres execution environments all speak gRPC API and talk to the brain, to the cloud, your cloud. And then on top of this, Matriarch exposes interfaces, such as a web console and a command line interface. So you can connect remotely. And the key is that this web console and this command line run from anywhere. It doesn't matter where your nodes are. They can be on-prem, behind firewalls. You can go to the public website of the brain, of the Matriarch, and just connect and manage your Postgres clusters from there. If the demo works, I'll show you. So, who wants demo? Let's give it a try. All right. It's going to be a bit hard. Yeah. My connection, I'm using services that are, I guess, not working well from usual connection. So I'm connected from my phone to Spain, and from there to the US and back and so on. So let's see. Is the font size okay here? Is that okay? Okay, awesome. So first of all, I'm just going to create, the first thing we need is instances. We need Linux boxes, right? So I'm going to create 3 instances now. Let me run the command, I'll explain what I'm doing later. Yeah. You know what is this? Ooh. Tofu is the open source clone of Terraform. So this is fully compatible with Terraform code, as you can see. Go back a little bit. Yeah, there's too much output here, but, well, actually, if you look at the present working directory, this is Terraform code. I don't have any. So, what I'm doing in this command is just automation to create 3 instances. I'm creating 3 instances in AWS in Singapore region. Okay, so we're not that far from them. And these are the instances. You can see, they're not creating still. I will use these instances to create a managed execution environment, and then I'll create a Postgres cluster. You can bring any instance, any Linux you want, it doesn't matter. Okay? I'm just creating instances here. I just wanted to make sure that you believe that they're not prepared. I'm creating them empty, just with Ubuntu Linux. Okay? Now, I'm going to go to Matriarch, which is exposed to a web console. So let me log in with GitHub here, and we should be from. Okay, great. Demo effect. But I think now it's going to go while this create the instances, which seem to be created already. Yep, let me just make this a little bit smaller. So I can use this command, for example, to get a session in one of these boxes. And by the way, here we logged in already, good. When I make the font size, it's okay, yeah, it's pretty big, right? So, good. And here I have, this is again, an empty Ubuntu version, so I can say, all right, so this is the OnDB console, and here there's nothing yet. Here they have managed resources, no Postgres, no nodes. So the first thing we need to do is plug the nodes so that they can be managed. Easy. Copy and paste this command, and I'm going to run this command on the newly created instance. Okay? This should take just a few seconds, and basically this installs the OnDB software and this node, and will become a managed node. Basically, this is installing Sloanee, if you remember from my previous slides. Copy and paste from here, right? Just one command, and oops, node's already here. And indeed, I already managed the node, and it's already running here. So far, we haven't done pretty much anything, just having a managed node here that we can list. I can see that it's not running any Postgres instances there, and let's see that it's Sloanee connected. Good. Let's repeat this for the other 3 instances so we can create bigger clusters. So let me log out from there. Let me connect to the other one. I'm just going to repeat the process very quickly, hopefully, so that you don't get bored. Let's add a new node. Again, another token. This is not the case. Tokens cannot be reused. And let's copy this one. Let's run this one. And it's basically doing the same, right? One command, copy and paste from the web console, run in a Linux box. This Linux box doesn't have anything, it's bare Ubuntu 24.04,
nothing installed on it, okay? And very soon, it will appear here. All right, it's already there, very nice. And when this finishes, it's done. I'll connect to the third one, so I'll have the 3 instances. That will help me go through my demo. And connecting there, I'll get a new token. Let's refresh this actually faster. And copy paste. Easy, right? Copy, paste. There we go. And I'll have the 3 minutes in a few seconds. That's all it takes to create what we call a managed node. Again, and from this managed node, we can now go and create Postgres clusters. I'm just going to wait for the third one to be, there we go. So we've got the 3 nodes. We can see here indeed. And actually, you can see there's auto detection here, so they realize that they're in Singapore region, Asia-Pacific Southwest region one. This says Singapore for Amazon, and they are all on different availability zones. It's a good pattern to create a Postgres cluster. So let's try to create a Postgres cluster. New Postgres cluster. So first, I select the version, whether it's standalone. Let's create a high availability cluster to get started. And assign a random name. Let's going to select the version of its latest, whatever that means. And now I need to perform the node selection. And here I'm listing the nodes that are available, that are managed, and I can decide where I want to create them. So actually I want to use the 3 instances now. And then I can select extensions. And here I have a list of extensions. We'll have more later on. We're planning to supporting hundreds and hundreds of extensions, but let me pick a couple now just to have some extensions. And let's just go and create a cluster. And cluster created successfully. Actually, it's in the process. You can see here in the bottom a little bit. And here we can see how the cluster is going to look like. It's all running on Amazon Cloud. This is the IP of the node. And we can see that the instances are being created. Let's wait a few seconds, and we should be ready to go. And basically, this is all that is needed to create your own Postgres cluster with high availability starting from OnDB apps. This is the same as a managed service, except that it runs on your hardware, on your instances, anywhere you want. Right? It takes a few seconds depending on internet connection. Here we go. Yep, that's it. What it was like 20, 30 seconds. And now I have perfectly wired my Postgres cluster. I can click here, and now I can see all the details. See, it's going. Let's use this. It's over here actually. I can list the instances. They're all healthy. I can see that this is the primary, the size of the nodes, and everything. And I can also see some events that happened during the creation, and so on. I can also click on the individual instances, see more details where the files are running and all the paths. The events for any individual instance, I can even pull the Postgres logs from here, which is also very convenient. So pretty much I will be finished with my demo, except I wanted to show a couple of things more. First of all, let me create another Postgres cluster. I'm going to create a standalone, and look at this. Not saying anything, but there's Ivory. Let me click on that. So let me create an Ivory cluster. And I'm just going to keep it like this. I'll select the nodes. I picked a single node cluster, so I'll pick an instance. You can create also multiple instances within the same managed servers, right? And so in a few seconds, hopefully, we'll get also an Ivory SQL cluster running here. While this creates, let me go back briefly to the slides. And, well, just in case the connection did not work, I had a lot of screenshots here just in case, right? There's something else that I would like to show you, and is this part. On top of having a remote CLI, which I'll also show you now, and the web console that I'm also showing you, we have introduced a way to run pSQL from the web. It goes directly to your servers, right? So let me try to show this. So here we have this single node clusters already created, and here I have this command open terminal. If I click, I should get my terminal running. And this is ISQL. Right? This is not running on the browser. I mean, the command line is running on the browser, but just to show that this is also, I mean, it's very obvious that it's ISQL. But the key is that Postgres server is running in Singapore in Amazon, in these virtual machines that I just created before. Okay? It took me a few seconds to create this, and I got it already running. Now, this console is running from anywhere. It's actually running from my laptop, right? I'm connecting from anywhere, and it connects and pushes down all commands to my databases out there. Let me do just the last while thing. Let's see if this works. Let me now log out from there. I want to connect to one server at home in Spain. Okay? This is the risky part. Okay. Kind of works. Let me also create a virtual machine so that again you see there's nothing prepared here. It's also Ubuntu 24.04. Let me connect exec, connect to this VM. Let me install curl, because this is so basic that there's not even curl installed on this server. Oh, there's curl. Okay, I got it. Let me add a new node. Let's copy this command, paste it. Remember now my console is in Spain, okay? Okay. Reload this. Inspired, whatever. It's still, of course, still in development, so there's some rough edges here and there to polish. But should be able now to install this. Okay? I have a pretty good connection there. So we'll have a fourth node appearing here very soon. There we go, right? This node is on-prem, so you see there's no icon. There's no cloud here. Now, this also comes with the OnDB command line. And this is again running in Spain. But I can still say something like cluster list. And I get my two clusters, my Postgres cluster and my Ivory cluster, that are running on instances on Singapore without public IP, by the way. Okay? And I can say OnDB cluster, get and this random name, pipe the output, and I can see all the details, right? I can list my cluster, understand the extensions of the version they're installed, and instance by instance, I can see that this is a replica, this is a replica, this is the primary. The IPs, you can see there are private IPs and all that, right? So the size of the database. So I can manage my clusters from here. And I can also do something really cool. Let me install Postgres client here. So PSQL. My bad. So PostgreSQL client. You can see that this is so bare bones just created, right? This VM. And now I can do OnDB cluster list, just remember, and I can say OnDB cluster PSQL. I'm gonna pick one instance, for example, which one was the primary? This one, number 2, right? So I'll say, connect to the primary. This gives me the SQL console. So what I'm doing here, I'm running this command line in Spain, and it's giving me a console against my Postgres server running in Singapore, all in public and private keys. This is the power that we want to bring you. To have a web console, to bring your command line, where you can manage from anywhere you are in the world. I've tried this, by the way, while I was flying here at 30,000 feet with not Starlink, with the old generation plane technology, and being able to manage my Postgres clusters anywhere where they are, private EPs, defined firewalls, all within my web console or my command line. And that's pretty much all I wanted to show you today here. Here you can see the screenshots, and that's all. Any questions?
Yeah, on your PSQL console, what would happen if I do !rm sudo rm/xr?
Well, I mean, the environment is totally open for you to do anything. So,
Just died or?
yeah, let's run it. I mean, that's why we actually play with them. You have full control. That's the key, right? We're providing you full control. So if you run the command, okay, I see it's not enabled. Yeah. Okay. Yes. No, this is good because what actually I believe should be running. I mean, it's not working, but could be working. So basically, the way this works is because we're creating. Well, actually, technology is a bit more complex, but we're creating a tunnel for the Postgres protocol from the web console, so from the web to a proxy server, from the proxy server to Matriarch, from Matriarch to the Slowly, and from there to your Postgres cluster. So your Postgres cluster sees a connection coming from localhost. It's just the command is not exposed.
It's not in the cluster, it's somewhere.
No. Yeah.
It's just a single command.
This command line
Command line.
is not doing this. Actually, if we try from here, I believe, let me try it here. I believe it should work. Yeah, you see? Yeah, it works. Our goal is to give you all the power. The environment is yours. If you screw it up, your problem. I want to give you the freedom.
Thank you.
All right, thank you so much. If you have any further questions, feel free to find me and talk to me. Thank you.